Welcome to this introduction to the decision matrix. Remember, we're using the decision matrix at the developing a solution stage of our design process. The decision-making matrix, taking a closer look at preliminary ideas. And we're going to use this primarily to help us as a group decide what is the best solution for us to use here. A decision matrix is used to compare design solutions against one another using specific criteria that are often based on project requirements. In this example, you see on the left-hand side all of our ideas. So those could represent each of the, for our example, draw lanes that you and your partner will be using. At the top, going across the top, you're going to notice that we have some of those criteria. Cost being one, complexity, how much time it would cost to develop, and then we total that. We base it off of a scale, either 4 through 1, 4 being best, 1 being the worst, or yes or no, 2 or 1, 2 being yes, 1 being no. You want to use the scale that will best fit, and for ours probably will be, to get the most variety, will be the 4, 3, 2, 1 scale. You have to be very cautious here in making sure that when you decide to use these scales, how you are going to evaluate and make sure that you're consistent, so that a 4 is always a 4, 3 is always a 3, etc. So in this example, what material would be best for creating models of puzzle pieces? We have dice, we have clay, we have blocks of different types, we have caramels, and we have sugar cubes. So idea number 1, modeling clay is reusable, readily available, requires some forming, can be sticky, and it's an imprecise geometry. Idea number 2, which are caramel cubes, they're cheap, readily available, pre-shaped, sticky, impressive geometry, imprecise geometry, but on the other hand, they're really good, which could be a problem. Our dice are expensive, they are reusable, they require two-sided tape if you want to stick them together, they're moderately stable, and they have a very precise geometry. Notice the categories are the same. With these cubes, Fisher-Technic blocks, they're cheap, reusable, they interlocked, they do have some protrusions, so that would affect our overall geometry, but it is precise. And then finally, foam blocks. They're expensive, but they are reusable. Again, require this two-sided tape. They can fall apart easily, so over and over again, use would probably become a problem, and the imprecise geometry because you can squeeze them and deform them. And then our last one is actually the sugar cubes. So here we have cheap, readily available. They do require glue if you wanted to stick them all together. They do have the granules that come off, which can cause a mess, and they're not consistently the same in geometry. So what are our criteria? They're going to be cost, the reusability, geometry, connections, cleanliness, resilience, testability. These would be the items that we would put at the top of our scale or our matrix. Other things we could add: function, product lifespan, development time, size, material cost, development costs, manufacturing costs, company standards, manufacturing capabilities, and safety. When we're developing the decision matrix, here's the grading scale. It must be developed to assign values for each criteria in each category. So we have the rank scale and the question scale. Again, we'll probably be using the rank one. Here's an example of how we're going to do it. So when we look at it, we look at modeling clay, and we're going to assign these rankings based on best being 4 and then to worst being 1. So in modeling clay, we see that the cost here is a 2, caramel cubes are 3, dice 1, interlocking centimeter cubes is 4, foam cubes 1, and sugar cubes 4. And that is based solely on cost. Going to do the same thing for each of these other categories. you and your partner would be working on this. Again, assigning, working together as teams to decide how you would measure or rate each one of these. And then at the end, you total. And the one which ends up with the best overall total score would be the one that we'd end up choosing. So the right decision, which would be, in this case, idea number 4, the design decisions should be based on analysis and logic, not personal opinion. So you can't have ownership over your own drawings and go in with the attitude that I'm just going to measure these all 4s so that mine ends up winning. So basically, don't be biased towards your own drawing. A decision matrix is a design tool that may be used multiple times throughout a design process, so we can keep going back and reusing it. That is the decision matrix. Hopefully you can use this video in order to properly evaluate which decision you and your partner will choose for each of our projects.